All right, we're going to cover two sections today. Section 6.2 is going to show us how to factor trinomials, and specifically in 6.2, the trinomials are going to look like this. These type of trinomials are going to have a leading coefficient of +1. Okay, and in section 6.3, we'll learn how to factor the more difficult types of trinomials where the leading coefficient is not +1. To factor these types of trinomials, what we are going to do is we're going to use what's called the product sum method. So I like to make a little table over here. The first column is called the product column. The second column is called the sum column. And what we need to do is we need to find two factors that multiply together to give us our constant term C. And suppose that we discover that there are two factors that multiply together to give us our constant term of this trinomial C, which are C1 and C2. Okay. So we need two factors that multiply together to give us our constant term here, C, whatever our constant term is. And what we would do is we would put those, we would put these factors down here that multiply together to give us C. And then these factors have to add up or sum up to our middle coefficient of B. B is called the middle coefficient of the trinomial. And so C again is called our constant term. So if we can find two factors of our constant term that add up to our middle coefficient, then essentially we have accomplished our task here. And now once we find two factors of our constant term that sum up to the middle coefficient B, we can immediately factor this trinomial into the product of two binomials. And so this trinomial would factor into the product, so there's multiplication in between here, of the two binomials of x plus c sub 1 times x plus c sub 2. That would be the factorization of this trinomial here. All right, so these are the type of trinomials that we're going to learn how to factor in section 6.1. So let's just try several of these here. Suppose we want to factor x squared plus 7x plus 12. Well, our product has to be positive 12, which is the constant term over here. And our sum has to be the middle coefficient, which is positive 7. So we're going to start searching for factors of positive 12 that add up to positive 7. Now, if you cannot think of what those factors are, if you can, that's more power to you. But if you can't, you might want to just start listing factors of 12 by starting with 1, trying 2, trying 3, climbing the ladder. That way you won't miss any. So 1 times 12, 2 times 6, 3 times 4. All of these factors are factors of positive 12. And over here we would entertain the sum of these factors. So we would have 1 plus 12 gives us a sum of 13. 2 plus 6 gives us a sum of 8. 3 plus 4 gives us a sum of 7. Now, technically, there are negative factors of 12, like negative 1 and negative 6, negative 2 and negative 6, negative 1 and negative 12, excuse me. negative 2 and negative 6, and negative 3 and negative 4. But these are a waste of time because two negatives add up to a negative. Our middle coefficient is a positive 7. So we're wasting our time in listing these negative factors here. So the only two factors of positive 12 that sum up to positive 7, our middle coefficient, would be 3 and 4. Notice these are the only ones that add up to give us our middle coefficient of 7. Being the case, this trinomial immediately factors into the product of two binomials, of which would be x plus 3 times x plus 4. And we are done. That would be the factorization. Or you could have these factors switched around. It doesn't matter. You could have x plus 4 times x plus 3. At any rate, this would be the factorization of that trinomial. And of course, to check your answer, if you FOIL this out, you would get back your trinomial. X times x would give you back x squared. X times 3 is 3x, plus 4 times x is 4x. 3x plus 4x is 7x. And 4 times 3 gives you 12. So this would be the correct factorization of that trinomial there. All right, let's try another one here. Let's try to factor x squared plus 3x plus 2, making our product sum table here. We need a product of positive 2. Our constant term has to be positive 2. Our middle coefficient is positive 3, so the sum has to be positive 3. So we're searching for two factors of positive 2, the constant term, that add up to the middle coefficient of positive 3. The only factors of 2 are going to be 1 and 2 and negative 1 and negative 2. But negative 1 and negative 2 do not add up to our middle coefficient of positive 3, so these don't work. The only ones that work are 1 and 2. 1 plus 2 does add up to our middle coefficient of positive 3. So the only factors of our constant term positive 2 that sum up to the middle coefficient of 3 would be 1 and 2. Hence, this trinomial immediately factors into the product of two binomials, which are going to have first terms b and x, and the last terms would have to be plus 1 and plus 2. And that trinomial is completely factored. And it doesn't matter, again, if you put the x plus 2 here and the x plus 1 here. The order doesn't matter here. But this would be the factorization of that trinomial. All right. So this is called the product sum method. Let's see if we can try a couple more here. Let's try to factor y squared plus 3y minus 18. So again, this is a trinomial where the leading coefficient is 1. To factor these types, we tend to use the product sum method. And this table is helpful. Now, when you get better at factoring these types of trinomials, you can probably abandon the table here and speed this up a little bit. But for now, I'm going to use this product sum table. So our product has to be the constant term, which is negative 18, and the sum of our factors have to add up to positive 3, the middle coefficient. So I'm going to start listing factors of negative 18. Negative 1 and 18 are factors of negative 18. Positive 1 and negative 18 are factors of negative 18. Negative 2 and 9 are factors of negative 18. 2 are positive 9. 2 are negative 9, rather, are factors of negative 18. 3 and negative 6 are factors of negative 18, or negative 3 and positive 6 are factors of negative 18. And there you go. Now in this list, we're searching for a couple of factors that sum up to positive 3, the middle coefficient. Well, it's certainly not negative 1 and 18 because these add up to 17. It's not 1 and negative 18 because positive 1 and negative 18 add up to negative 17. Negative 2 plus 9 add up to 7. Those don't work. 2 plus a negative 9, they sum up to negative 7. Those don't work. 3 plus a negative 6 add up to a negative 3. Those don't work. And finally, we strike oil, if you will, on negative 3 and 6 because negative 3 plus 6 add up to our middle coefficient of positive 3. So therefore, the only factors of negative 18 are constant term that sum up to the middle coefficient of 3, would be negative 3 and 6. And that being the case, this trinomial now is going to factor into the product of the two binomials of y minus 3 and multiplied by y plus 6. Y minus 3 times y plus 6. And we're done. This is your factorization. Keep in mind, you could have these switched around. You could have y plus 6 times y minus 3. All right. That one's done. Let's see if we can try another one here. We will try to factor x squared minus 1x minus 30. Product sum method. So I need a product. I need a product of negative 30, and my sum has to be in the middle coefficient, which is negative 1. So I need two factors of negative 30 that sum up or add up to negative 1. So the search is on. So this list factors of negative 30, negative 1 and 30, or 1 and negative 30, negative 2 and 15, or 2 and negative 15, negative 3 and 10, or 3 and negative 10, negative 5 and 6, or 5 and negative 6. So here's all the factors of negative 30. The list is quite extensive. We're searching for a couple of factors in this list now that sum up to negative 1. It's not going to be negative 1 and 30 because they add up to 29. It's not going to be 1 and negative 30 because negative 1 and 30 add up to negative 29. It's not going to be negative 2 and 15 because these add up to 13. It's not going to be 2 plus a negative 15 because these add up to negative 13. So what is it? It's not negative 3 and 10. These add up to 7, no good. 3 plus a negative 10 don't work. They add up to negative 7. How about negative 5 and 6? Well, those miss it by a sign. These add up to a positive 1. Finally, 5 plus a negative 6 we discover is the combination we need because 5 plus a negative 6 add up to our middle coefficient of negative 1. So the only factors of negative 30 that sum up to our middle coefficient of negative 1 are 5 and negative 6. That being the case, this trinomial is going to factor into the product of two binomials, namely x plus 5 times x minus 6. And this would be the factorization of that trinomial. Again, you could have these switched around. You could have x minus 6 times x plus 5 here. Okay. All right. Let's try another one here. T squared minus 13t plus 42. We will try to factor this trinomial here. Again, it's a trinomial of the type where the leading coefficient is 1. That's what section 6.2 is all about, is these types of trinomials where we have a leading coefficient of 1. To factor this trinomial, you will use the product sum method. All right, we must have a product of 42. That's our constant term. And our sum must be negative 13, which is the middle coefficient here. So the search is on to try to find a couple of factors of positive 42 that add up to negative 13. Like I said, when you get good at these, those two factors will probably just pop into your head. But for now, we may have to list them out. Now, it is a waste of time to list the positive factors of 42, as two positives add up to a positive, and our middle coefficient is not a positive, it's a negative. So these are a waste of time to entertain the positive factors of 42. Hence, we should be entertaining only the negative factors of 42. So negative 1 and negative 42, negative 2 and negative 21, negative 3 and negative 14 are factors of 42. 4 doesn't divide evenly into 42, 5 doesn't, 6 does, negative 6 and negative 7. And therefore, in this list now, which two factors sum up to negative 13 are middle coefficient? Well, it's not negative 1 and negative 42. These add up to negative 43. That's not even close. That's not even close to negative 13. Negative 2 added to negative 21 add up to negative 23. These don't work. Negative 3 added to negative 14 add up to negative 17. Those don't work. Finally, we discover that negative 6 added to negative 7 add up to negative 13, our middle coefficient. So the only factors of positive 42 that add up or sum up to negative 13, our middle coefficient, are negative 7 and negative 6. So this trinomial factors immediately into two binomials, namely t minus 6 times t minus 7. And we're done factoring that trinomial. All right, now your author may slip in a couple of trinomials that have two variables in them instead of one. For instance, x squared minus 13 xy plus 42y squared. Okay. Well, to factor this trinomial, ladies and gentlemen, is essentially done the same way as the previous one was done. Notice our leading coefficient of the trinomial is 1, our middle coefficient is negative 13, and we do have 42 at the end. The only difference is we have a y variable thrown into the mix. But it works essentially the same way. We need to find two factors of our positive 42 here at the end that sum up to negative 13, the middle coefficient. And we discovered that those two factors that work would be negative 6 and negative 7. Hence, this trinomial will factor immediately into the product of two binomials. The two binomials have to be x minus 6, not just minus 6 though, but minus 6y, times x minus 7, not just minus 7, but minus 7y. And there you go. This would be the factorization of this trinomial. So the only difference between this one here and the previous one up here is the fact that we have a y thrown in the end here. Okay, that's the only difference. Okay, let's try this one here. A squared plus 2ab minus 8b squared. We'll try to factor this trinomial here. And notice again, it's the type where the leading coefficient is 1. So to factor this type of trinomial, we need our product to be negative 8. And we know we need our sum to be the middle coefficient, which is positive 2 here, positive 2. So we're searching for a couple of factors of negative 8 that add up to positive 2. And I'm going to start listing factors of negative 8. Negative 1 and 8, 1 times a negative 8, negative 2 and positive 4, or we could switch the signs and say 2 times a negative 4. These are factors of negative 8. Now, which two factors in this list add up to a positive 2? Well, it's not negative 1 and 8. These add up to 7. It's not 1 and negative 8. These add up to negative 7. Negative 2 plus 4 add up to a positive 2. 2 plus a negative 4 add up to a negative 2. So the only factors of negative 8 that sum up to the middle coefficient of positive 2 would be negative 2 and positive 4. Being the case, this trinomial is going to factor into the product of two binomials, which are going to have factors of a minus 2, but not just minus 2, but we got to throw in a b at the end, so minus 2b. The other factor will be a plus, not just 4, but plus 4b, a plus 4b. And we are done. This would be the factorization of that trinomial. All right, we'll try another one here. Let's try to factor x squared minus 5xb minus 36b squared. Well, we need our product to be negative 36 here at the end, and we need our sum to be the middle coefficient, which is negative 5. So what are two factors of negative 36 that add up to negative 5? Well, we can start listing factors of negative 36, negative 1 and 36, 1 and negative 36, negative 2 and 18, or 2 and negative 18, negative 3 and 12, or 3 and negative 12, or negative 4 and 9, or 4 and negative 9. Or we could have negative 6 and 6. Now in this list, we're searching for a couple of factors in this list here that sum up to negative 5. It's not going to be negative 1 and 36. These are way off. These add up to 35, not even close to negative 5. These are a waste of time. Negative 2 plus 18 isn't going to work. These add up to 16. We're still way a ways away. We're far away still from negative 5. 2 added to negative 18 add up to negative 16. No good. 3 plus a negative 12 would be a negative 9. We're getting a little closer, but we're still not there. Looks like negative 4 and 9 would work here. One of these. Is it going to be a negative 4 plus 9? No, these add up to a positive 5. We need them to sum up to a negative 5. So it looks like it's going to be 4 and negative 9 as being the only factors of negative 36 that add up to negative 5, our middle coefficient. Therefore, to factor this trinomial, knowing the factors have to be 4 and negative 9, this trinomial would factor into x plus 4b, x plus 4b times x minus 9b. And we're done. That would be the factorization. So that's what section 6.2 is all about here, ladies and gentlemen, is learning how to factor trinomials of the type where the leading coefficient is positive 1. That should propel you to do the homework problems out of section 6.2. And obviously you have the luxury of being able to rewind this and watch this video over and over and over again. I would also recommend that you look at the examples in section 6.2 that your author worked out. That would be an excellent way to solidify this information in your mind. All right, section 6.3 is having us factor difficult types of trinomials now. And these trinomials are going to be of the form of ax squared plus bx plus c, where a, the leading coefficient, is no longer equal to 1. So these are going to be the difficult types of trinomials to factor. We no longer are going to have a leading coefficient of 1. To factor these types of trinomials is a little bit more involved. Okay. And what we're going to do, ladies and gentlemen, is I'm going to show you, there's two main methods for factoring these types. There's the trial and error or guess and check method, and there's also what's called the grouping method. I tend to like the grouping method because it minimizes the amount of guessing you have to use or the amount of trial and error. So I do opt usually for the grouping method for factoring these types of trinomials here. Okay. The idea behind this method is we kick this method off by taking the product of the leading coefficient and the constant term. So our product is going to be A times C, the product of the leading coefficient and the constant term. And our desired sum is still going to be the middle coefficient, which is going to be B. So you can see that this method looks very similar to the method we used in section 6.2 in factoring the easy types of trinomials. You'll see where the method deviates though. All right, now we're trying to find a couple of factors of A times C that add up to positive B. Suppose that those factors were like C sub 1 and C sub 2. Suppose these are factors of AC that do indeed add up to our middle coefficient of B. So what we would do now is we would rewrite this trinomial as an equivalent 4-term polynomial. So we would say our trinomial is equal to ax squared. Now this middle term is going to get split up and rewritten into the sum of our decided upon factors over here. So bx is going to be rewritten now as c sub 1x plus c sub 2x plus your constant term. And what we would do now is, because we have a 4-term polynomial, we would revert back to section 6.1 and using what's called the grouping method for factoring this 4-term polynomial. So we would group together our first and last two terms using parentheses. And then we would try to factor something out of both these terms, ultimately enabling us to factor this trinomial into the product of two binomials. So this essentially illustrates what's called the grouping method for factoring these difficult types of trinomials where the leading coefficient is no longer positive 1. Okay, I'm going to demonstrate several of these. Now, the thing with this method is it does have some steps, as you can see. But once you get comfortable with this technique, ladies and gentlemen, through practice, you're going to literally fly seamlessly through these steps. Okay, so these problems are not going to really seem that bad once you get accustomed to this technique. All right. All right, so let's see if we can solve a couple of these difficult types of trinomials in section 6.3 using the grouping method. The first one we'll try to factor is going to be 2x squared plus 7x plus 3. So we want to factor this difficult trinomial here using the grouping method. So to initiate the procedure, we take the leading coefficient and multiply it by the constant term of 3. So our product here is going to be 2 times 3, which is 6. That's our product. And our sum is going to be the middle coefficient, which is positive 7. So what we need now are we need to find two factors of positive 6 that add up to the middle coefficient of positive 7. So listing factors of 6, 1 and 6, 2 and 3. Notice, don't waste your time in listing the negative factors like negative 1 and negative 6 or negative 2 and negative 3, because two negatives add up to a negative. Our middle coefficient is positive. So these are a waste of time in this situation here. So which of these two factors add up to 7? Well, 1 plus 6 are the ones that work. Those are the factors that sum up to 7. And because of that, we're now going to rewrite our trinomial as an equivalent 4-term polynomial. So I say equal 2x squared. The middle term 7x now is going to be split up and rewritten as the sum of our decided upon factors over here. So 7x is going to be rewritten as plus 1x plus 6x. And you got your plus 3. Now that we have an equivalent 4-term polynomial for our original trinomial, we're going to use grouping to factor this 4-term polynomial. So we throw parentheses around our first two terms, and we place parentheses around our last two terms. Out of the first two terms, I can factor out an x, and I would leave behind 2x plus 1 in doing so, plus, out of the last two terms, I can factor out a 3, leaving behind 2x plus 1 in doing so. Now you can see that both these terms have a common binomial factor of 2x plus 1 here. Being the case, I can factor the 2x plus 1 out of both these terms, and here it is, times what would I leave behind in doing so? Well, when you factor 2x plus 1 out of the first term, you're going to leave behind just x. That goes here. When you factor 2x plus 1 out of the second term here, you're going to leave behind just a plus 3. And ladies and gentlemen, this is the factorization of this difficult trinomial up here. This is called the grouping technique for factoring that difficult trinomial. Let's try another one. Okay, so we will factor this one here. We have 2n squared minus n minus 3. We're going to try to factor this difficult trinomial using the grouping method. To initiate this, we take the product of the leading coefficient and the constant term. So that gives us a product of 2 times negative 3, or negative 6. And our sum of interest for this trinomial is going to be the middle coefficient, which is negative 1. So now the search is on, ladies and gentlemen, to try to find two factors of negative 6 that add up to negative 1. Listing factors of negative 6, starting with 1, trying 2, trying 3, and climbing the ladder so you don't miss any, we would have negative 1 and 6, 1 and negative 6, negative 2 and positive 3, or positive 2 and negative 3. These are all the factors of negative 6. Now we're searching for a couple that sum up to our middle coefficient of negative 1. Negative 1 and 6 don't work. These add up to 5. 1 and negative 6 don't fit the bill. These add up to negative 5. Negative 2 plus 3 add up to a positive 1. But remember, our middle coefficient is a negative 1. So none of these work, but the last situation does work. 2 added to a negative 3 add up to our middle coefficient of negative 1. Hence, the only factors of negative 6 that sum up to our middle coefficient of negative 1 would be 2 and negative 3. Being the case, we now rewrite this trinomial as an equivalent 4-term polynomial where the middle term gets split up and rewritten into the sum of 2n and negative 3n. Again, the 2n comes from our choice of factor of 2 here, and our minus 3n comes from the choice of the factor of negative 3. We now group together our first and last two terms here to try to factor this 4-term polynomial. Notice I have a minus sign that precedes my third term, in which case we have to be very careful in how we group our last two terms together. To avoid a sign mistake, I'll leave this minus sign outside the parentheses, but then I'll have to change the sign of my last term from a minus to a plus. Now what can I factor out of the first two terms? I can factor out an n, and that will leave behind 2n plus 2. Oh, you know what? I should have factored not just an n out, but what? 2n. Should have factored out a 2n. So that's not correct. Hold on a second. Let me make this correction here. That's no good. So what I should have factored out of the first two terms is 2n, because 2n is the greatest common factor of 2n squared and 2n. And when I factor 2n out, I leave behind n plus 1. Last two terms, I can factor out a 3 out of 3n and 3. And when I do so, I'll leave behind n plus 1. Now we can see that we have a common binomial factor of n plus 1 shared by both this term and this term. Being the case, I can factor out the common binomial factor of n plus 1. There it is. Times, what do I leave behind? Well, when I factor n plus 1 out of the first term, I leave behind just 2n. When I factor n plus 1 out of the second term, I leave behind minus 3. Ladies and gentlemen, this is the factorization of that difficult trinomial. This illustrates the grouping method. One more note here. It doesn't matter what order you list these factors here. We decided upon 2 and negative 3. I could have just as well have had minus 3n plus 2n here. You would get the same factorization as what we got down here. It's just that these factors would be switched around. You'd have 2n minus 3 times n plus 1. Okay. Let's try another one here. All right, how about 6x squared minus 13x plus 6 we want to try to factor this difficult trinomial using the grouping method. To initiate this, we take the product of the leading coefficient and the constant term to give ourselves a product of 6 times 6, which is 36. And our desired sum has to be the middle coefficient, which is negative 13. So the search is on now to try to find two factors of positive 36 that add up to negative 13. Since our sum must be a negative, it would be wise for us to list only the negative factors of 36. In other words, listing positive factors of 36 here is a waste of time because two positives add up to a positive and not add up to a negative. So I'm going to list only the negative factors of 36, negative 1 and negative 36, negative 2 and negative 18, negative 3 and negative 12, negative 4 and negative 9, or we could have negative 6 and negative 6. Now we're searching for a couple of factors in this list that sum up to negative 13, and the only ones that add up to negative 13 would be negative 4 and negative 9. So the only factors of positive 36 that add up to negative 13 would be negative 4 and negative 9, as none of these other ones sum up to negative 13. Being the case, we're now going to rewrite our trinomial as an equivalent four-term polynomial, where the middle term, negative 13x, gets split up and rewritten as the sum of negative 4x and minus 9x. Now we're going to factor this four-termer by grouping. Again, we have a negative sign that precedes our third term, so be careful how you group your last two terms together, leaving the minus sign outside the parentheses. I changed my plus 6 into a minus 6. Now what can I factor out of 6x squared and 4x? The greatest common factor of 6x squared and 4x is going to be 2x. When I factor 2x out, what do I leave behind? Well, 2x times what gives you back 6x squared? I'll leave behind 3x. Minus 2x times what gives you back 4x? I'll leave behind 2. Minus, what can I factor out of 9x and 6? I can factor a 3 out of both these terms, and when I do so, I leave behind the binomial of 3x minus 2. Now we can factor the common binomial factor of 3x minus 2 out of both these terms, since it's common to both terms. There it is. Times, what would I leave behind? Well, when I factor 3x minus 2 out of the first term, I leave behind just 2x. And when I factor it out of the second term, I leave behind minus 3. And there you go, ladies and gentlemen, we have the factorization of this difficult trinomial. This is illustrating what's called the grouping method for factoring difficult types of trinomials. That is the order of business in section 6.3 here. Okay. Try another one here. We'll try to factor this difficult trinomial here using the grouping method. Notice there's nothing you can factor out of all three of these terms here except 1 or negative 1. And so to kick this off, we take the product of the leading coefficient and the constant term. So the product of interest is going to be 20 times a negative 5, which is to say negative 100. And our required sum is going to be the middle coefficient of negative 48. So we're searching for a couple of factors of negative 100 that add up to negative 48. Well, what are factors of negative 100? Negative 1 and 100 or 1 and negative 100? These don't work because negative 1 plus 100 add up to 99. We must have them sum up to negative 48. 1 and a negative 100 don't work because 1 plus a negative 100 add up to negative 99. Negative 99 is not negative 48. Negative 2 and 50 are factors of negative 100, and notice negative 2 plus 50 adds up to a positive 48. We're getting close. So we'll switch the signs on these. How about positive 2 and negative 50? These are factors of negative 100, and these finally add up to what we need, namely negative 48 for the middle coefficient. So the only factors of negative 100 that sum up to negative 48 would be positive 2 and negative 50. Therefore, ladies and gentlemen, we now rewrite this difficult trinomial as an equivalent 4-term polynomial, where the middle term, negative 48x, gets split up and rewritten in the sum, into the sum of 2x minus 50x. Or you could have minus 50x plus 2x. The order in which you list these don't matter here. I'll say plus 2x minus 50x. Now that we have an equivalent 4-term polynomial for our trinomial, we will factor it by grouping. So we put parentheses around the first 2 terms and the last 2 terms. Notice we must change the sign of the last term here because we have a minus sign preceding our 3rd term, of which I keep outside the parentheses. Out of the first 2 terms, I can factor out a 2x, and that will leave behind 10x plus 1. Out of the last 2 terms, I can factor out a 5, leaving behind 10x plus 1. Notice now we can factor that common binomial factor of 10x plus 1 out of both terms. There it is. Times what would I leave behind? Well, when I factor 10x plus 1 out of the first term, I'll leave behind 2x. And when I factor it out of the second term, I'll leave behind minus 5. And ladies and gentlemen, there's your factorization of that difficult trinomial. Again, illustrating the grouping method. All right, maybe try, maybe one more might be good enough. Let's try to factor one like this. Suppose that we have 2 variables entering into the picture again. We have 3x squared plus 19xy minus 14y squared. Well, don't worry about the extra variable. Essentially, just pretend like the y is not even there temporarily. So just pretend it's like 3x squared plus 19x minus 14. We'll throw the y's in the end. Anyways, using grouping method for factoring this difficult type of trinomial, we're going to take the product of 3 and the negative 14 over here. And 3 times negative 14 gives us negative 42. And our sum of interest has to be in the middle coefficient of 19. So here we're searching for a couple of factors of negative 42. 3 times negative 14 is negative 42. That sum up to positive 19. Let's start listing factors of negative 42. Negative 1 and 42. 1 and negative 42. Negative 2 and 21, or 2 and negative 21. 3 divides into 42 evenly. 3 times 14, or we could have 3 and negative 14. 4 don't divide into 42 evenly. 5 doesn't. 6 does. Negative 6 and 7, or 6 and negative 7. Now in this list, which is quite extensive, we're searching for a couple of factors that sum up to 19, positive 19. After searching through these factors, the only ones that add up to positive 19 would be negative 2 and 21. Those are the only factors that add up to our middle coefficient of 19. Knowing that to be the case, we now rewrite our trinomial as an equivalent 4-term polynomial, where our middle term, 19xy, gets split up and rewritten into the sum of negative 2xy plus 21xy. And now we're going to take this problem the rest of the way by using the grouping method. Since we have a 4-term polynomial equivalent to our original trinomial, we group together our first 2 terms by placing them inside the parentheses. Notice we do not have to change the sign of our last term here because we got a plus sign in front of our 3rd term here. Out of the first 2 terms, I can factor out an x, leaving behind 3x minus 2y. Plus, out of the last 2 terms, I can factor out a 7 and also a y. And I would leave behind 3x minus 2y. Notice we have a common binomial factor of 3x minus 2y that can be factored out of both these terms, and there is the 3x minus 2y times what do we leave behind? When we factor the 3x minus 2y out of the first term, we leave behind x. And when we factor it out of the second term here, we leave behind plus 7y. And there you go, les amis. This would be the factorization of this difficult trinomial here, once again illustrating the grouping method. So this should propel you towards having success in factoring some difficult trinomials, those that do not have a leading coefficient of 1 in section 6.3. I will update the homework and give you ample practice. I usually require just the odds to be done, but if you want extra practice, please do the even problems too, as I will post the solutions where you can check your answers for both. All right. Thank you for listening, and I'll see you this next week.